So welcome back to the second part of the 18th lecture of spatial statistics and spatial econometrics. And in this lecture, we will be discussing causal inference in spatial regression models. And when I speak of causal inference, I'm specifically referring to the assumption 2 of the linear regression model that we covered in lecture 16. So a very quick recap for your benefit. The linear regression model, a simple linear regression model looks like the following. It's yi equals beta 1 plus beta 2 xi plus ui, right. Assumption 2 states that expectation ui given xi is equal to 0. That is to say, given every value of xi, the expectation, the value ui, the random error will be in expectation 0. That is to say, that model error is going to be 0 for every given value of xi. This is critical for us to simulate the ceteris paribus experiment for causal inference. Right? What was a ceteris paribus experiment? Well, we were looking at an example of the impact of number of rooms on housing prices as an example. And we said that if number of rooms go up by 1 unit, that is Ri were go to Ri plus 1, then whether or not this change in the space or the spaciousness of a house can be causally related or causally linked to the change of price from, let's say, pi to pi tilde. This change can only be causal if all else is held, only if all else is held constant. And to be able to ensure that all else is held constant, what we must also ensure is that the expectation of ui is the same at Ri and Ri plus 1, right. This meant that we wanted to ensure that expectation of ui given Ri is exactly the same as expectation of ui given Ri plus 1, which or both of them are going to be 0 by the definition of the assumption itself. Okay. So the idea is to be able to attain causality, a causal linkage. We also saw and covered in that lecture that this is also key to unbiasedness of least squares estimate. So data driven estimates of these beta 1 and beta 2, they are only unbiased if you have A2 satisfied. Okay. So now we will figure out how this manifests for in a spatial regression model. So this is a classical, the traditional regression model as we are used to. Now we are going to move to a spatial regression model and see how this condition comes about. So in order to see that, we are going to study a seminal paper by Charles Mansky, who is a an economist who wrote a seminal paper on identifying the endogenous spatial effects, and he called this problem a reflection problem. This reflection problem, as stated by Mansky, relates very closely with the endogeneity of spatial effects or the unidentifiability of the spatial effects. So let's define these effects. Let's go over Mansky's definition and then adapt it. Then we will adapt it to the spatial regression models. So Mansky defines endogenous spatial effects as the propensity of an individual to behave in some ways co-varies with the prevalence of that behavior in some reference group containing the individual. Now that's a very heavy sort of a statement. What it really is saying is that an individual, the way an individual behaves or the decisions that an individual takes, if it co-varies or it correlates with the behavior or the decisions of a group in the population that we are working with, right? So an individual's behavior is somehow mirroring the behavior of a group. Then what happens is that we are not able to understand whether the group is impacting the individual behavior or simply reflecting it, right? So this is the core reflection problem, wherein if I am trying to understand the behavior of an individual and I find that behavior to be similar to other individuals in some reference group, then we do not know who caused that behavior. Is the group causing that individual to imitate that behavior, or it is simply a reflection of the way the individual is performing or behaving in a population? Okay. What is this reference group? Well, the reference group, first of all, is within a population of interest. So we are looking at population. We are trying to understand population dynamics. We are searching for a reference group. It could be a socio-economic identity, a family background, or even an economic class. It's a strata, a group within a population where people behave in similar, with similar traits in terms of their consumption patterns, in terms of their occupational patterns, in terms of their day-to-day, everyday living choices. Okay. Now that is what an endogenous social effect is, where an individual's behavior, there's a propensity of that being reflected in a group's behavior and vice versa. Now, endogenous social effects are also called as, now these social effects, the endogenous social effects, have been very popular in sociology, in social psychology, and now also in economics. Bransky wrote this paper in 1993. So, economists were grappling with social effects for quite some time, and we will see how. So the point is that the terminology with which endogenous social effects appear in different literature is quite varied, and it has many names. Those names are social norms. So sometimes there are these social norms or peer influences that people are impacted by their peer group, right? Neighborhood effect, something that we have seen with housing prices. Conformity, imitation, contagion, bandwagons, herd behavior. All of them are referring to the fact that people are behaving as herds. Everybody tends to converge with the same ideas, same decisions, and so on and so forth, right? So there is a tendency to conform to a social group, right? It's hard to defect from what everybody else may be doing in a particular social group, an ethnic group, or a socio economic group, or family background. It drives a lot of how people make decisions in the real world. Then there are things like interdependent preferences, right? As economists, we study these devices called preferences, which are about how individual, would order or rank, elements of their choice set. Now, if an individual is ordering or ranking elements of a choice set can be consumption goods. It could have recreational parks. It could have anything. Sports, which sports channel to watch, and so on and so forth. If my preference of how I order the sports channels that I like to watch is dependent on other individuals in my peer group, then that exhibits endogenous social effects. So as I've said, economists have been concerned about endogenous social effects that are mediated through markets. So typically, when economists talk about endogenous social effects, they are talking about the effects that are generally mediated through markets. The first, most common, is the price mediated effect, where how does an individual's demand for a product vary with market price? This is a typical question that an economist asks, is to say, how will the demand for milk vary by its market price? How will the demand of cigarettes vary by its market price? These are questions that are found in economics literature. There's large literatures of this kind. Now, this market price, however, is determined at least partly by the aggregate demand in a relevant market. So the prices that we see in a market for any good is exhibiting a general population level or a group level or a city level willingness to pay for that, for that entity, for that object, right, for that good. Now, if an individual is buying that good, they are somehow imitating the behavior of their reference group, this group which is also willing to pay that price for that very object, right? So there are these endogenous social effects, but they are mediated through market prices, so through a market equilibrium. Again, there are models of oligopoly that posit reaction functions which link an individual firm's output with aggregate industry output. Again, it's a very similar idea, but now on the using a production function rather than the consumption or the consumer preferences. Now, if decision making is costly, right? If it is costly to make decisions, if it brings stress to someone in making decisions, right? If someone feels that they have to acquire a lot of knowledge, they have to read a lot before they make any decision, right? Then the tendency is to rely on someone else's, to copy someone else's decision, right? This is also a form of endogenous social effect that economists have documented. I'm providing you a reference of 1980. So in 1980, Conlisk was documenting decisions which were very costly, either on time or some other factor, knowledge, capital, or some other factor. It's a costly decision. So an individual or a group of individuals are found to imitate others just because it's very hard for them to find out all the information about the relevant decision that they are making. There is also documentation of residents choosing not to live in neighborhoods where the percentage of residents from their own race or ethnic group is below a threshold. Again, an individual decision somehow imitating the decision of a or reflecting a decision of a reference group. Here in this case, the reference group is not through markets but by race or a social class, a social strata, which could be ethnic groups or races or whatever, right? So all these examples had existed in the economics literature, which were then formalized by Mansky as endogenous social effects, as follows. So Mansky states that the reflection problem arises when an econometrician, that is a researcher, an analyst, that is us, observing the distribution of behavior in a given population, desires to infer whether the average behavior in some group influences the behavior of the individuals that comprise that group. Now, this is a heavy statement, so let's break it down into pieces. So we are talking about an econometrician who is desiring to infer something, okay? So the econometrician is desiring to infer whether average behavior in some group will influence the behavior of individuals in that group, okay? And what is the information set for the researcher or the econometrician? It's the distribution of behavior in a given population. So you are able to, see the population at an aggregate level, right? If you are able to, for example, see the groundwater extraction at the country level for different districts or for different villages, then you are trying to understand whether an individual village is somehow exhibiting the average behavior of all the villages in a given state or in a given region, and so on and so forth, right? So when we are trying to say that average behavior in some group will influence, what we are interested is a causal link and not a correlation, right? This is the key that in social sciences, we are mostly interested in causal links and not just correlation. Okay. So now the term reflection signifies simultaneous movements of an individual and her reflection in the mirror, here the mirror being the reference group. So the fundamental query is, does the mirror cause the individual's movements or merely reflect them, right? So the problem of causality versus correlation is that if we are not careful about which direction the effect has gone, they are simply associations. They could go either way. It could be, the mirror causing an individual's movements, or it could be a reflection of the individual's movements, right? So this, when we are trying to put a causal link where we say, no, the group behavior, average group behavior is influencing individual decisions, that directional, establishment of a link in terms of a quantitative effect is called as causal inference. Okay, so reflection problem is that I am behaving in certain way, my peer group is behaving in a certain way. From a distant to a distant observer, we both look quite similar in terms of our behavior, let's say in terms of investing time in studying econometrics, or in times the number of hours I invest studying in a week versus leisure. So if me and my peer group are exhibiting similar features in terms of the time we invest in studying and in recreation, then it's very hard to figure out whether I am reflecting the group's behavior or the group is reflecting my behavior, right? It's like two mirrors kept in front of each other, right? But we are trying to understand a directional effect, that what is the peer effect on my day-to-day activities. Okay, so in this spirit, we are now going to, with this background and understanding, we are now going to consider a linear model, and we are going to look at the endogenous social effects through a linear model. So we are going to work with a population that is characterized by a value y, x, z and u. Okay, y is the outcome variable or dependent variable, like for example housing price. X is the characteristic describing an individual's reference group. Now reference group could be an ethnic group, it could be family background, it could be an economic class, right? It is a reference group to which this individual affiliates. It could even be a union, right, of some kind. It could be a student body of some kind, right? Y is my decision, my outcome variable that I'm trying to understand, I'm trying to explain. X is the group in which I, being the observee, belong to or affiliate with. Z are the factors, Z and U, they both affect Y directly. For example, the number of rooms in case of the housing market affect Y directly. The public amenities in a neighborhood affect Y directly, that is housing price directly, right? The observed ones in these direct impact factors are denoted as Z, and the unobserved ones are denoted as U. Now U, we are working with regressions, is going to be a model error, so U is going to be a random variable, okay? So we specify y equals alpha plus beta expectation y given x. What is expectation y given x? This means it is the mean or the average group outcome, right? Whereas on the left hand side, what you have is individual group outcome. How is it group outcome? Because it's conditional on some characteristic of the group itself, right? Then plus gamma expectation z given x. This expectation z given x is the attribute, the average attribute or factor size for the group. That is, let's say in the housing price, if I am looking at a certain group which is, let's say, near the railway station, then I am going to see number of rooms, average number of rooms, in homes or houses located near the railway station. If near the railway station is x, then that's what Ez given x is. This is the mean of explanatory variable, mean of explanatory variable z in the reference group, okay? And eta z plus eta z, now eta is model parameter, z is the direct impact, that is number of rooms of that particular house that we are studying the price for, okay? So eta is now z is the individual level explanatory variable, right? And u is the model error, something that we have talked about many times now, right? And also I am saying that expectation u conditional on z and x is delta x, right? So, so the mean of error conditional on the group characteristics and the explanatory factor, right, is equal to delta x. Okay. Remember, this is saying that this is not equal to 0. If delta is not equal to 0, this is going to spell trouble in terms of the second assumption. Okay. Now, beta not equal to 0 refers to what is called as the endogenous social effect. What is the endogenous social effect? The endogenous social effect represents the propensity of an individual to behave in some way that varies with the behavior of the group. This is the endogenous social effect that we are talking about, right? This is something we have defined till now. Gamma, on the other hand, is termed as the exogenous effect. Exogenous effect is also called as a contextual or contextual effect. Okay, context is something that sociologists and anthropologists take very seriously, right? So gamma here is representing what is called as the contextual effect. The contextual effects are wherein the propensity of an individual to behave in some way varies with the exogenous characteristics of the group. Okay. So now an exogenous characteristic that is explaining why, we take this exogenous characteristic, aggregate it onto the group level, and then look at the effect of that on the individual y. So this is a variable which is saying the average number of rooms in homes located near the railway station, where near the railway station is x. Okay, that's the characteristic of the group that we are studying. The last one, which is delta, which is coming from the model error, is called as the correlated effect, wherein individuals in the same group trend to behave similarly because they have similar individual characteristics or face similar institutional environments. Okay. So this is a group level characteristics. Obviously, X is about groups and it's coming through expectation of U, which is the error unobserved terms, but in mean or on average value, this is the effect, the propensity or the component that is causing equivalency or similarity in behavior between the individual and the group by the fact that individuals in the group are similar, right? They face similar institutional constraints and so on and so forth. Okay. Okay, so now as I said, this condition that expectation u given z comma x is non-zero is where A2 is violated. That is, we no longer have causal inference, we merely have a correlation or an association. How do we establish this mathematically? So now let's look at the model that we have. Y equals alpha plus beta expectation y given x plus gamma expectation z given x plus eta z plus u. One thing that I have not said till now, alpha, beta, gamma, eta and delta are all model parameters. Okay. Then the mean regression of y on x and z, mean regression of y on x on z basically is talking about a situation where you have a plot, a scatter plot of y and x, right, and the regression line is expectation y given x, right. This is the regression line equation or regression line. Okay. Now instead of y given x, it's saying run this regression, the mean of y conditional on x and z. So now in the conditional statement, I have two entities x and z, and I will take this and I will run this expectation on both sides. So I am going to take expectation on the left hand side, I am also going to take expectation on x, z, and then expectation everything x, z. Okay, that is what I am writing here. It's basically alpha plus beta expectation y given x plus gamma expectation z given x plus eta z plus delta x. Okay. Now integrating both sides with z reveals what is called as a social equilibrium equation. Z is the exogenous factor, right. If I integrate it out, all I am left with is the group characteristic x and the endogenous social effect. So now I am going to relate these two and I'm going to find expectation y given x. So from here to here, see that z has been integrated out. So that means that I am basically, you know, doing something like this. So I have f of z dz on the domain of z. So I've gone from this to this. I've integrated both sides in this fashion. I've integrated z out of this, I'm going to have alpha over 1 minus beta. How did that happen? Because now if when I've integrated this out, I have expectation y given x here and expectation y given x here. I bring it here. I get 1 minus beta on the left hand side and I divide the whole thing by 1 minus beta. Okay. So alpha over 1 minus beta plus gamma plus eta over 1 minus beta expectation z given x plus delta over 1 minus beta x, right. So you can write, 1 and 2. I'm sure that you will be able to figure it out. Okay. Now, expectation y given x is the linear function of 1. So the 1 is the, intercept, column of 1s. It's also linearly related with expectation z given x, sorry about the typo there, and x. So it's linearly related with 1, the expectation of z given x and x. As a consequence, the model parameters alpha, beta, gamma and delta are all unidentified. This implies that the endogenous social effects cannot be distinguished from either the exogenous effects, which is z, or the correlated effects, which is x. So this problem of the reflection problem basically says I cannot distinguish between the betas, the gammas and the deltas. Okay, I cannot tell beta apart from either gamma or tell it apart from delta. This is the problem of this effect, right? Okay. Okay, so I'm going to end this part of this lecture of lecture 18 here, and in the next part we are going to now adapt this problem of endogenous social effects to the spatial regression model, and then we are going to see it with the spatial lag, probably giving a similar flavor as expectation y given x, which is what caused the problem in the previous case, and then from there we are going to see how do we fix this problem. Okay, so thank you very much for your attention. See you in the next part of this lecture.